this video segment, we are going to demonstrate how to build the application for our mixer sequence with the use of the CCW software. We will start by launching the CCW start or splash screen. We're going to open an existing project that already has the tags created for us. The first thing we need to do is configure our PLC. On the General tab, we need to give our controller a name, and if we want to download the source code. If no is selected, an upload will not retrieve the code from the controller. On the Ethernet tab, we need to set the IP address where we are going to use for the PLC. Last is the plugin/expansion module section, where you need to configure any additional I/O that is added to the controller. If the I/O is not added in the configuration but does exist, it will cause a fault. Same with the opposite, if you add I/O that does not really exist. Now that we've configured the PLC, we are going to go to our programs icon and then select and add a ladder diagram. It will create a new program called prog1. This is where we are going to add logic for our sequence. In our first step of the sequence, we said that we always need to maintain that we are in auto. Therefore, I am going to add a XIC or direct contact, and then we are going to go to our global variables and select the tag called system mode. System mode has a comment. If it is 0, it means manual, and if it is 1, it means auto. Then we select OK. The next condition in the step is solenoid 3 must be off. So we are going to select an XIO or reverse contact instruction and pick the tag solenoid 3. Another way you can add the next condition for sensor 1 is by selecting solenoid 3, pressing Control C and Control V, and then change the tag to sensor 1. Last, we will add our output for solenoid 1. To do that, we will add an OTE or coil instruction and create the tag name called solenoid 1. This completes the first step and rung of our sequence. We will follow this approach and build the logic for solenoid 2 and the motor. We can copy our entire rung 1 and modify it to meet our new conditions. The new conditions are system mode is on, solenoid 3 is off, sensor 2 is off, and sensor 1 is on. Let's copy the sensor 1 instruction, then we change the tag to sensor 2. Then we can change the instruction for sensor 1 to be XIC by selecting the instruction, moving to the property panel, and changing it from a reverse contact to a direct contact. Now this is a personal preference, but I always like to have the last condition of the rung be the condition that will trigger the output. This is especially true when you are building a real sequencer. Last, we need to change the output for solenoid 2, as well as add a parallel branch for our motor output. We do this by selecting our toolbox and click, hold, and drag the branch out to the spot in front of our solenoid 2 output. Then we copy the solenoid 2 coil and paste it on the new rung and change the tag name to motor 1. Now that solenoid 1 and 2 are built, we are going to build solenoid 3, which is slightly different because we need to stay on even if the conditions to turn it on are no longer on. This can be accomplished by using a set and reset coil or using a self-latching circuit. We will be using a self-latching circuit in today's demonstration. We will first start with the logic to turn on our output, which is system mode is on, sensor 1 is on, and sensor 2 is on. To make the circuit stay on even when sensor 2 or sensor 1 turn off, we need to add a parallel branch around them with an XIC instruction for solenoid 3. This means that the initial conditions are true, it will turn on the output. And when the output turns on, it will keep itself on. The last part we need to program is what will turn off solenoid 3, which is sensor 1 has been off for 10 seconds. Let's start by adding another rung and adding a timer or TON instruction. For our timer to start timing, we need to have solenoid 3 on and sensor 1 off. Next, we need to add our preset time. And you can hard code this time by using the format T#10S. CCW timers have a few different format options, such as H for hour, M for minutes, S for seconds, and MS for milliseconds. Now that the timer has been created, we can change the name of the timer by right-clicking the object, selecting the block selector, and changing the instance name at the bottom of the pop-up window. With the new timer named, we are going to use the timer done or Q bit to turn off solenoid 3. We do this by adding a XIO after all the input conditions and reference the timer.Q bit. This will complete all the logic we need for our sequence. Now we will need to build and download the logic so that we can test and make sure we have done it properly. Let's build our project to verify that it is okay. Now we need to verify our communication path and connect to the PLC. If it does not exist, then you can select the pen icon and open links to browse to the controller. Then you can download by selecting the drop-down button in the taskbar, or you can hit the connect button that is right next to the connection path. After hitting connect, you get a prompt asking if you want to download or upload. Right now, we are going to download. Then you will get another prompt if you want to download or download with project values. We are going to download with project values since this is the first time we are downloading to this controller. When we do this, you will see that the run light on the controller itself turns off. The light being off is an indication that you are in program mode, which allows you to take the information from the PC and store it in the controller. Since our mode switch is in remote, our last prompt shown is, do we want to put the PLC back into a remote run mode condition? This will finish the download and go online with the controller so we see the logic in real time. To test our scenario today, we are going to simulate a few conditions. The first thing we are going to do is turn on the signal for auto mode. Now that we are in auto mode, our first step of our sequence is to open solenoid 1 until sensor 1 turns on, meaning we start to add ingredients to our tank. We are now going to simulate that we have filled up to sensor 1. This will turn off solenoid 1 and it will turn on solenoid 2 and the motor. Now we are mixing and adding our second ingredient into the tank. We are going to continue to fill until sensor 2 is turned on. When sensor 2 turns on, it will shut off all the remaining equipment and open solenoid 3. Our last step in our sequence was to leave the dump valve open for an additional 10 seconds after sensor 1 turns off. Simulating our scenario, sensor 2 will turn off first. The next condition will be that sensor 1 turns off. Now you will see the timer starts counting. When we reach the 10 seconds, our timer output will turn on. The last bit will happen rather quickly, but when the timer hits the 10 seconds, the timer output will turn off solenoid 3, and when solenoid 3 turns off, it will also reset the timer. For our practical example, there are a lot of ways in which you could make the system better. We ask that you think about that and feel free to contact Hayden and I if you want to review any possible improvements. Now that we have verified our program, we should save and upload to store any potentially changed values into our offline project. We are going to start by disconnecting from the controller so that I can upload. Opening CCW with the launch or start page and then select Discover. This is going to launch links. Then we need to select the proper driver to browse and find our controller. Then you can select OK, and it will upload all the contents inside the PLC, regardless of the firmware or specific hardware. In our scenario, since we have the program backup, you have the ability to select Upload, and that will finish our programming demonstration.